Welcome on this International Webinar Week. As you know, it's a pleasure for us to welcome you today, and thank you for having accepted our invitation. It's very kind of you, and we appreciate a lot. Before giving you the floor for a 30 minutes presentation followed by a 15 minutes Q&A, let me present you on the topic of your presentation in a few words. You are the Executive Director for Rumble Buildings Business Unit. So Rumble is a multidisciplinary engineering, design, and consultancy service company operating in the world, designing more than 10 million square meters of buildings every year. Sustainability is a top priority in your work, and it is through your design you have the biggest impact on the world around us. Lars, you have 20 years of design experience as well as business skills in developing and evaluating the feasibility of solutions. This has resulted in strategies for transforming cities into carbon-free communities without burdening public budgets. You are also setting up and sponsoring the internal Rumble Sustainability Network, including strategies for zero carbon buildings. The network develops new ideas, new concepts, and new solutions, which are subsequently implemented in projects. You have delivered several talks at international conferences, and we are happy again to welcome you on our first international web conference on net zero carbon. And all these talks were focusing on sustainability, urban development, livability, energy efficiency, and so on. So you are a very good expert today for us and for our internet followers and students. And you will present us today the role of embodied carbon in buildings and how to reduce it. So thank you again. And Lars, I leave you the floor.
Well, thank you very much, Frederick. Let me first share my screen. First of all, thanks for the introduction. And again, I'll just repeat what you said, that Rumble is a company founded in Denmark in 1945, so 75 years ago. And we have then grown to many countries in the world. We are designing buildings and infrastructure for transport and for energy and for water. And we are working a lot also with the environment and health issues of the world. And we have a management consulting arm to help us with the business aspects of all these issues. I'd like to start by setting the scene. So when we design buildings today and for the last couple of decades, we have tried to do it as sustainably as possible. And in order to balance all the different aspects of sustainability, we typically use some of the certification schemes like BREEAM, LEED, or DGNB. And there are 40 or 50 other similar schemes around the world. What they do is that they list typically all the aspects of sustainability, which is different from country to country. So that's why we have so many different schemes. And then basically in the design process, we try to achieve the best possible performance within each of these aspects. And then we, the scheme will give you points. And when you collect points at the end, you achieve a rating. So a rating of maybe silver, gold, or platinum, or whatever the different schemes is using as a rating. And this is really great. You can see also on this overview that some of the schemes emphasize on the environment. Others are more holistic and takes everything, including social and financial sustainability, into account. So there is no one definition of sustainability because it changes from country to country, it changes over time also. And so we also know about the UN sustainability goals that was introduced in 2015. And again, these are for 15 years. I'm sure that when we reach 2030, it will be different goals that we will be focusing on. Because, you know, when we focus on solving a problem, very often we succeed in solving that problem, and then we go to the next problem to solve, and then it's a different problem that is the biggest problem. So basically, in the 25 years of my personal experience of designing buildings, things have changed all the time. And we've had a decade of focus on operational energy. We are now entering a new decade where we may focus on what we call embodied energy or embodied carbon. We will also focus on resources, so that's kind of the circular economy agenda. And we might, you know, in the future find other issues that is going to be more important than the ones we focus on at this time. So we ask ourselves, I ask myself whenever I start a new project, you know, what is it that is most important for the client at this point in time? And so we do this sustainable buildings market study every second year. We've just completed a new one, which will come out next week for all to read. What it does is it asks a number of questions to more than 1,000 property owners that we work for. And then we ask them what is important at the time, for the time being. And what I can disclose at this point is that net zero carbon buildings, of course, is a very big topic. And I think that's what we are all talking about. This is what this webinar is about. But also what's coming up on the agenda is circular economy. As a second priority, a lot of talk in the EU about circular economy. And if you look ahead, you know, we do use a lot of raw materials, and also some of these raw materials are limited. So we really have to think about how and you know, what raw materials we use in the future. Plus, we generate a lot of waste, and so there is an issue here that we have to focus on also, circular economy. And then thirdly, you know, sometimes we forget about people. Sometimes we forget that, you know, the buildings we design are for people, and we are so enthusiastic about saving energy and getting that to zero that we forget that, you know, the people live in these buildings. We really have to also make sure that they are healthy and the people are happy, you know, when they live there. So that's the third item that you know, clients are focusing on at the moment. We've seen some certification schemes focusing solely on well-being. So there is this WELL standard, I'm sure a lot of you have heard about. The Swan label certification is about chemicals in construction materials. You know, we talk a lot about smart buildings. How can we make buildings more intelligent to provide a better living experience? So again, you know, when we go and talk to our clients, what we do is we bring up this, we call it the sustainability dialogue tool, and we sit down with them before we do any design, and we ask, what is important for you? Is it the CO2 emissions? Is it the circular economy? Is it the health and well-being? Or is it, you know, 5 other topics that I've listed here? And so that is a way to prioritize what is important. And then after that conversation, we know how to focus the design on achieving good performance within the areas that the client think is important. Typically we cannot achieve good performance in all areas at the same time. It's always a kind of a balance. If not, then because some of them can cost money, and so there is also a limited budget available for most buildings. But I'm going to go back and talk about the carbon emissions. And the reason that this is important is we all know that from all the carbon emissions in the world, about 39% comes from buildings. And for decades, we've been trying to minimize the operational emissions. And that is still the majority of the emissions, because most of the buildings we have in the world today have been there for many years. And so they have not been designed in an energy efficient way. So there is definitely a big task for us to look at the existing buildings and how we can design that. But on the other hand, we've also made really good progress. And so I'll come back to, when we look at new buildings, the buildings we design today, the majority of the emissions come from what we call embodied carbon. And so why do we think it's important to focus on the embodied carbon? Well, here is a chart showing the building codes in Denmark, but it's basically similar in most other European countries. From the building regulation in 1969 was the first time when we actually set a requirement, a maximum allowable energy consumption requirement. And then we had the oil crisis. We had other things that, and finally in the last 20 years, we had the carbon emissions, the climate changes and so on. So we had different drivers that drove down the operational energy use in buildings. And so for new buildings today, the building regulation of 2020 has what we call a nearly zero energy buildings standard, a very, very low energy use. And so we've almost solved the problem for new buildings. Of course, if you look here, you can see to the left, if you look at the average of all buildings, and again, this is for Denmark only, so it's different in the rest of the world. But if you look at existing buildings, the average is still very high. So there is some way to go. But this will always also be helped by the transition of the energy system. So the electrical grid, district heating, and other utilities that we have will automatically be decarbonized, so that the electrical grid in 20 or 25 years will be carbon free. So the problem of operational energy will, if we don't do something, it will still go down, will still be somehow solved. It doesn't mean we don't have to do something. We still have to do as much as we can to reduce energy consumption, but we are on a good path here. That's my point. But if you look at what we call the embodied carbon, this is all the energy that we use when we produce materials, when we construct and build the buildings, also when we change during the lifetime of the building, when we change or refurbish components in the building, when we demolish the building, and when we recycle the materials. There's a lot of energy used and a lot of carbon emissions from that. We did a study together with a university in Denmark last year, 2020, of 60 buildings. And here is the results, which shows with a 50-year lifetime how many kilos of CO2 is emitted from each of these buildings, from embodied carbon and from operational carbon. And as you can see, if you take it per year, it's between the lowest is about 6 and the highest is maybe 13. So that's quite typical. This is life cycle analysis data. So we've looked at all the emissions throughout the lifetime, and this is why it's important that we talk about the emissions per year, because if it's a 50-year lifetime, then we divide by 50. If it's a 100-year lifetime or different, then we divide by 100. I think what is most important here is that the embodied carbon, the blue color, is much higher than the operational carbon over the lifetime of the building. So the operational carbon, because of what I just showed you about building regulation and so on, is going to be very, very low for most buildings. So the biggest problem we have going forward is embodied carbon. And that's why we have to focus on that. Another interesting aspect of that study we did last year is if you look at the typical time, the lifetime aspect of these buildings, there's a lot of emissions in the first year, because this is where you manufacture the material, you produce the building components, and you build the building. So that's what is causing a lot of emissions. And then, every 15 or 20 years, when you do an upgrade of something, maybe it's the mechanical system, maybe it's the internal walls or the facade, there will be additional emissions. And then at the end, when you demolish the building, there are also emissions. It all ends up typically between 300 and 500 kilos of CO2 per square meter. But what you see here is that there's one building that stands out and that has a negative carbon emission flow, which is a timber structure building. So that's because the way we look at it, when we build with timber, we store the carbon that is absorbed from the atmosphere into this timber. So that's what we call sequestration. So that is stored throughout the lifetime of the building, and then depending on what we do with the timber, it is then released to the atmosphere again. It's different from concrete and steel, where we use a lot of energy, and in the process of producing cement, there's a lot of carbon released, and that's why it's different from those materials. If you look at look at the types of buildings that we have, it's almost the same. It's not exactly the same, but it is almost the same. So for whatever building, you can see here between 300 and 500. So it's not very significant difference from one type to the next. What is interesting is in what parts of the building is the embodied carbon, where does the embodied carbon come from? Well, the majority comes from the structure, and because of what I just said, steel and concrete is the main emitters of embodied carbon. But of course, also there's steel and concrete in other parts, and there are aluminum and plastics and so on. So there is a lot of places where we can look at. So basically, the agenda for when we design buildings has changed. The political agenda has changed. We're no longer so interested in how many kilowatt hours per square meter per year is a building using, because energy is not a problem so much in the future. It's going to be renewable and carbon free and so on. What is really interesting is what are the carbon emissions? So how many kilos of carbon emissions per square meter per year? That's what regulation needs to address. That's what we have also, this is 2 years ago, we have worked with the World Green Building Council on a report where we laid out a roadmap for until 2050. What is it that we can do to bring embodied carbon on the agenda, to make politicians aware of this problem, to make the whole industry, the designers, the contractors, the building material manufacturers aware. That is the big problem, and that's a report that we produced. In the report, we suggested that by 2030, all new buildings, infrastructure and renovations will have at least 40% less embodied carbon with significant upfront carbon reduction, and all new buildings must be net zero operational carbon. So the red part of the chart I showed you before must be zero. The blue part must be reduced by 40% by 2030. That's a very realistic target, but we need everybody to help achieve that. And then we said another thing for 2050, new buildings, infrastructure and renovations will have net zero embodied carbon, and all buildings, including existing buildings, will have net zero operational carbon. So that's the ultimate goal. That's the Paris Agreement, and any other agreement that has been made is targeting 2050 as the zero carbon, the start of the zero carbon future. So how do we get there? Well, this is a chart that we made when we internally in Ramboll, we're looking at how can we help reach that target. And we believe, there's a big part, of course, that needs to be done through new cement technology and carbon capture and storage. But there's a lot we can do already in the design that we as a design company can do. We can specify other kinds of cements with lower carbon emissions. We can, what we say, challenge the brief. That is, we can ask questions to the client about what he is building. Is it really necessary to build? Is it really necessary to build with those loads that he has specified, or can we do it in a better, less carbon emitting way? And also, can we increase utilization of the buildings we design, so that it's not, for example, if we design a school, it's not only used for a school, it's also used for something different in the evenings, so that we don't have to design so many buildings, so many square meters of space. We have to be very conscious what we build and stop building what is not necessary. One of the things that we are then really looking at, and because of what I said earlier, is how to use timber in buildings. And this is a very typical way to use timber instead of concrete. Project in London that we did a few years ago. The first floor is concrete, because this is where there are shops and longer spans, but then the residential units on top is all built of what we call CLT, cross-laminated timber. And it is almost a one-to-one replacement of a concrete structure, which would be the traditional way. Especially in the Nordics, we use a lot of prefabricated concrete, but we can replace all of those with prefabricated timber, CLT. So I want to just touch quickly on what is happening in different countries. This is going to be fast because I don't have the whole day. So Denmark has introduced regulation. Is planning to introducing regulation in relation to CO2 emissions. There is still a challenge in terms of getting data. How much embodied carbon does each material contain, and all of that has to be declared and calculated and declared. So that we have a couple of years to do, and then the new regulation will go into force. It's the same. Finland, this is a new report that came out of the Finnish Environmental Ministry. We have it in Norway, Norwegian Zero Energy Buildings Definition Guidelines. So a lot of guidelines are coming out. We have it in the UK from different sources. Here is an attempt to set targets for the next 30 years. For embodied carbon, and the Institution of Structural Engineers have recently published a guideline on how to calculate embodied carbon. Again, you can do it in many different ways, so we have to be consistent, because otherwise we cannot set targets. And so if you kind of look at it all together, there are regulation coming from almost in almost every country. In the Nordic countries, this is where we do a lot of our work, in the UK, also in France and Germany, Netherlands, and so on. So we can expect, although it's not there as we speak today, we can expect that a lot of regulation will be in place over the next few years. So no matter if you want it or not, you really have to understand the issues of embodied carbon, how to calculate it, and how to minimize it. What our clients are then asking, when we tell them about this, is, okay, how do I set a target? What is the appropriate target for embodied carbon in the buildings? And because of the constant reduction over time, these are some of the proposals that are already out there. If we're designing a building today, typically this is the British RIBA non-residential target. It would be about 800 kilos per square meter. And I think that is a quite achievable target. Most buildings automatically, even if you don't do anything, most buildings would be able to achieve that. We have a Danish building code where this is a regulation that we are expecting. The minimum requirement is going to be 600, and then there's an extra tough requirement for a voluntary sustainability class that is a little more than 400 kilos per square meter. So, and again, that will then change every 4 or 5 years, because then we will be coming down to something that is in the order of 40% reduction over the next 10 years. There's another way to look at it, which is, and again, this is still being discussed politically and in various fora. But we could also imagine that we would classify buildings according to a scale, A to G, in the same way as we do with energy efficiency. And then we say, okay, at the moment, a level F building is fine, but in 5 years, we would definitely expect to get a level D. In 10 years, we would expect to get a level B, and so on. So that's also another way to look at it, and we'll do that. I think the most interesting thing is, for any client to explain how can we actually reduce embodied carbon. And what we did was just to get a deeper understanding. We looked at 90 different projects we had made, and we then went back to see what concrete was used by the contractor, and we then mapped it on this scale to see the strength compared to the embodied carbon content. And as you can see, the very typical strength is 32 Newton per square millimeter, but you can get almost a factor of 3 if you don't specify how much embodied carbon you will tolerate, how much you will allow. So it goes from 176 to 462, very random, just by on the same strength of concrete, just without specifying anything. This is what you get. So first thing is, you can actually reduce a lot by just specifying that the maximum limit you will accept is maybe 200, and then the supplier of concrete will give you that. There is a database in the UK. There's a database also in other countries of embodied carbon per material. But really, if you look at what is the data in there, it varies a lot. So depending, for example, aluminium, depending on whether it's reused or virgin material, it can go from 2,400 to 58,000 kilo of CO2 per cubic meter. Same for the other materials. So it's not very helpful if you don't have the specific supplier and the specific specification of the material in mind. But as you can see, you can easily select material that has a low, is in the lower end, and then you can automatically get down. You can also look at, when you design the buildings, what is the span, what are the different solutions for deck slab solutions, and then you can select, even within concrete or steel, you can select different options that have a low carbon content. You can also select wood, of course, which has an even lower. And then, I'm going to run quickly over these because it's just, but if you compare and if you look at wood and you take the sequestration into account, then you will achieve a negative. Normally, on this slide, we have not taken sequestration into account. On this slide, you can see this is without taking that into account. Wood is still the best option, but if you even take sequestration into account, it's getting negative. We can look at facades. What are the different options? And then you get, this option 292 kilos per square meter. This option 465. So it's just about managing the carbon budget. It's about looking. This is maybe a little bit hard to understand. It's an abatement curve for embodied carbon in a project. The first thing you can do, you can both save money and save carbon, reduce volume of concrete, reduce cement content in concrete. And then there might be other things that will cost you more, but at the end, really make your building more sustainable. And we have the design process defined. It's almost the same in every country. You go from design brief. First, you have a strategic definition. You go to the design brief, and then you go through design stages. There's something you can do in every stage. So at the end, you can manage your carbon budget in the same way as you manage and financial budgets, and you do that. You already know how to do that. Every one of us is forced to do that. So I don't think there's a lot of challenges in also managing the embodied carbon budget. You basically, you set a target, you benchmark, what is it a similar building that has been built already achieved, and then you might, be more ambitious. You make estimates in each stage, and then you do what we call value engineer. If you then have selected materials and you find out, oh, I'm over budget, then you value engineer, you replace materials, or you do other things that comes down on budget, and then it goes up again in the next design stage. That's the kind of natural way that it works. And then you do value engineering again and bring it down, and so on and so forth. So that's how you would manage it. It's the same way as a financial cost budget.